Hello, welcome to the second video in the series of recovering from the effects of COVID-19 pandemic. This video focuses on manufacturing operations. Last week I came out with a video talking about 3 important things we should be looking at in order to recover from the COVID-19 pandemic, and this is a follow-up in that series. I also mentioned about an important metric in Lean which will actually help us to calculate how much of opportunity we have in order to reduce cost in operations. This is known as the velocity ratio. First, let's try to understand what exactly is velocity ratio. What you can see in this picture is a process which has many types of activities, both value adding and non-value adding. That's what you can see as the reality on top. And at the bottom is a figure which shows the desired level of flow in any operations process. So if a desired level of flow should take only, like, let's say 25 minutes or 30 minutes to go through in operations, it typically takes much longer for you to go through in an operations because of activities like waiting, transportation, machine downtimes, whip queuing, and so many other stoppages in your production floor. So, velocity ratio is the ratio of total time taken in any operational process to its optimal value-added process time. Dear friends, I will now show you how exactly to calculate a velocity ratio in an easy manner. Now, what you can see in this picture is over here, what you have is your raw material store. We are not going to do anything to what you have in your raw material store. And over here, you have your finished goods store. Neither are we going to do anything with what you have in your finished goods store for the purposes of this simple calculations. What you have from here to here is your operational processes. Now, we are going to add up all the inventory, or in other words, we also call them as work in progress or WIP. We are going to add up all the inventory from this point until this point. Whatever that is sitting over here, whatever that is sitting over here, or anywhere along this line. And let's say you have an inventory which adds up to 50,000 pieces. 50,000 pieces. Then you will have to identify your operations which are having 2 types of processes. One is value added processes. The other is non-value added processes. Now each one of this process, each one of this box represents a process in your operations. Like, let's say in a stamping factory, it could mean cutting, bending, shaping, and so on. Okay, and including processes like transportation, inspection, okay, whip holding, and so on. Okay, now we are only interested in the processes that add value. What are processes that add value? Processes that add value actually change the form, fit, or function of the product, and the customer is willing to pay for it. Okay, so there could also be other processes in your operations, like transporting, downtime, inspection. Okay, any process that actually does not add value to the customer, though you are doing it by requirement by your SOP, is considered to be non-value added from a lean manufacturing point of view. So we will exclude those operations or those processes in our calculation. So now let's assume this is a value adding process. Maybe it's a cutting, so I include the time for it. Maybe this is an inspection, so it doesn't add value, so I exclude it. So maybe this is stamping, so it adds value, so I include it. Maybe this is counting how many pieces you have stamped, it doesn't add value. Okay, and probably this one is bending or shaping into something else, so it adds value, so I add it. Probably this is another inspection, I exclude it. So what is it that I include? I include the process over here, I include the process over here, I include the process over here. I only have 3 processes which actually add value. Now let's assume the total time taken to process one piece in this operation, one piece in this operation, and one piece in this operation is 30 minutes. So I write down here 30 minutes. And the third figure we need is your daily demand. Now let's say your customer needs 25,000 pieces a day to be shipped to them. That is our daily demand. So we have a daily demand of 25,000. We have a total WIP in the system of 50,000, and we have a total of 30 minutes of value added process time. Now we are ready to actually go and calculate the velocity ratio. Let's take a look how we can do it. Now let's go ahead and calculate our velocity ratio. The first thing we are going to do is we are going to take our 50,000 pieces we had in the shop floor, which is our WIP, and we are going to divide it by the 25,000, which was the customer demand, and that is going to give us an answer of 2 days. I have 2 days worth of inventory in my shop floor. This is the first number that I need. The next is we already have a figure which tells us what is your value adding process time for one piece in your shop floor. That is actually 30 minutes. Now 30 minutes is equivalent to 0.02 days. 0.02 days. Now if I want to calculate my velocity ratio, I need to take this 0.02 days and put it over here, 0.02 days. Okay, so my formula to calculate the velocity ratio is the total time which I have in my process, which is 2 days, divided by the value added process time, which is 0.02 days. That is going to add up into a velocity ratio of 100. Velocity ratio of 100. Now what does this number tell me? Typically a world-class system, or we can also call it as a best-in-class system, which has implemented a lot of lean, which is very optimal in its operations, will be around a velocity ratio of 3.5. Now what is 100 compared to 3.5? That tells you that much of extra non-value adding processes, or extra inventory, or extra transportation time, or extra downtime you have in your system. That has to go down. So this is a number which tells me how much of waste I have in my system. Now 3.5 is usually a best in class for what we call as a discrete manufacturing process. Now if you have an operations where you manage things in a one piece flow in a conveyor system, you do not have big batches moving from one process to another, then a best in class ratio should be 1.5 instead of 3.5. Now this should be our benchmark velocity ratio numbers, and this is the velocity ratio which I have calculated for this example over here. So this number basically tells me that this operations has so much of room for improvement. I need to immediately go and diagnose where this waste is and reduce it. But this is the first step to calculate the velocity ratio. And this is one of the simplest method to calculate the velocity ratio. And it will not run very far from the actual exact waste you have in your operations. So you have learned how to calculate a velocity ratio. I hope this information has become very useful for you. Next week, I will be back with more tips on operational improvement and cost reduction. Thank you very much for listening, and hope to see you all next week.